Okay, welcome back. We're talking about the so-called range problem. A range problem basically means I want to put things in buckets. I'm sorting apples, and there are three different sizes of apples, and so the big apples go here, and the medium-sized apple goes in that bucket, and the smaller apples go in that bucket. That's the range problem. And so that's what we're doing here, and it's done with a series of else-if statements. And I don't have to say a B. I don't have to say greater than or equal to 80 and less than or equal to 90 because that test has already occurred. If this test is successful, none of the other tests will run. If this test is successful, none of the ones below that will run. If this test is successful, none of the ones below that will run. And then likewise, so the very last one doesn't actually need to have a test at all. In other words, if you're greater than or equal to 60, you got a D. If that's not the case, well, then I don't care what the number is, you're going to get an F, right? That makes sense? So this range problem is a very cool programming style of taking, like sorting apples or taking numeric scores and converting them into letter grades. Okay? Kind of sort of makes sense? Good. On page 210, they start talking about the switch statement. So the switch statement is pretty cool. The switch statement basically could go in and say something like this. I'm going to say switch, and then I'm going to use age. Maybe I shouldn't, but okay. And then I have these switch case. In fact, some people call it the switch case statement. So this is kind of sort of like the nested if thing, kind of, sort of, okay? But it has some really cool, it has some interesting limitations. So I'm going to say, 12. Well, then I'm going to do something. I don't know. Do a ET display. The answer is 12. Whatever. Like this. And then I'm going to put a break statement in here. And then I can have more cases. I could say case is equal to 13. Okay, and just keep going and keep going and keep going. I could have lots of these guys in here. Now, in this particular case, I'll admit this is kind of a stupid example because you could probably handle this a little better with just a series of nested ifs, okay? But I'm just saying this is how the switch works. So the switch starts with the switch thing, and then the expression that's being evaluated, in this case age. There's some rules here. The expression must be a whole number, like an integer or a long or a char, that kind of stuff, or a string. Well, what's left? If it's a whole number or a string, well, that means I cannot have pay rate. Remember the guy up here where I have pay rate is equal to 8.45? If I go here and say pay rate, the machine's going to complain and go, dude, switch statements only work with whole numbers and strings, and that's it. I'm going to do edit undo. Oh, well, there we go. Cool. Get it back to working again. So that's one of the rules. And the other rule is, I'm trying to make these rules kind of sort of simple, that every one of the cases ends with a break statement, okay? Now, the case values, that thing, I'm not sure what that's called. I call them case values, case arguments. I don't know what they're really called. Those things have to be literals or constants, okay? They cannot be variables, okay? I can't go in here and say case, num age or something. That won't work. So these guys have to be constants or literals, not variables. Here, they can be variables. I can say if score is greater than, top score, right? But I can't do that with case. So case is pretty cool, but it has some limitations. The first limitation is what can be in the argument, what can be in the expression, and that is counting numbers, whole numbers, strings, and that's it. And then the case statements itself have to be constant. In other words, you have to know the case values at design time. Here, I don't necessarily need to know, For example, what if this was just a filter for above average score? Okay. Well, I don't know what the average score is when I wrote the program. I generated it later on. So so this only works with things that you know at design time. Okay? Good. On page 212, they start talking about loops. So there's basically 3 different loop types. There's a while loop, a do while, and a for. There actually is a 4th one, but it'll be a while before we get to it. So let's start with page 213. They start talking about the while loop. Now there's 3 parts to a while loop. And so I'm going to deliberately go in and do these things. I'm going to say, I'm going to do int loop count is equal to 0. So I'm initializing my loop control variable. I often even abbreviate that LCV, loop control variable. So this is the first part. So this is like part 1. Part 1 is my loop control variable. And then I'm going to have a while loop, and I say while loop count is less than 10. So part 1 is I initialize my loop control variable. Part 2 is I use the loop, the LCV, as a test. As a test for what? As a test to stop or continue. So this is create LCV. And then later on inside your loop, I'm going to have to do something. So I'm going to copy because I don't like typing. And I'm just going to have it do loop count equals cool. All right. So that looks pretty good. Why don't I run this and see what happens? Well, that's a little weird. Nothing's going on. How come? I'm inside an infinite loop because I missed the 3rd part. The 3rd part of this is I need to alter my loop control variable. Almost always we're talking about incrementing, but that's not necessarily the case. So now part 3 is I change my loop, alter, whatever you might want to call it. Part 3, alter the LCV. Okay, now let's run it the 2nd time. Ooh, now that worked. Okay, so I started at 0 and went less than 10 for a total of 10. Remember how everything starts at 0? That kind of makes sense? So initialize the loop control variable, use it in some sort of a test, and then make sure you increment, because if you forget, nothing's going to work. Okay, let me stop this guy. And let's change this to while the loop is greater than 10. Okay? So let's run that one more time. And I got nothing. Well, why is that? Ooh, because the while loop is what's called a post-test loop. Post-test loop. No, it's not. It's a pre-test loop, which means the condition is going to be evaluated first. A pre-test loop means it may not run at all, depending on the value for count. Right? It may not run at all. Okay. So that kind of sort of makes sense. So I have to make sure this guy. So, for example, if I started this at 20, okay, right now, starting it at 20, is this loop going to run? Nope. Not going to run at all. Do you see why? Because the very first loop count says, in fact, this is pretty cool. Condition loop count is always false. Yeah. So it kind of sort of helps you a little bit there. Isn't that pretty cool? Okay, now it won't say that. Yay. All right, that kind of sort of makes sense. Okay, so on page 215 and 216, they start talking about the break and the continue. The break means I want off. You know, this merry-go-round is going around and around, and let me off the merry-go-round. Stop, I want off. And you get kicked out. But continue means, okay, I want the thing that, I just want to skip everything from this point on, okay? So, so for example, here, I'm going to say, I don't know, I want to skip number 5 for no particular reason. So I'm going to say if loop count equals 5. I don't know why. And then I'm going to say continue. Ooh, that's probably not smart. I'm going to have to do that on the other side of my increment guy. Well, doggone it. See, if I do a loop count equals... Okay, let me just run this to show you why there's a logic problem here. Continue means none of the statements at 97, 98, and 99 won't run. Okay? So if they don't run, then I'm back to that infinite loop guy because I can't get to line... I can't get to line 99, and I desperately need 99. So I'm going to just duplicate this. I don't particularly like to... This is one of those scenarios where I have to. Okay. Now, what this is going to do now is the loop is going to continue to run, so the continue doesn't kick me out of the loop permanently. It just means none of the stuff below me is going to run. So now it's just going to skip number 5. All the rest of them will work, but 5 won't. So it goes 1, 2, 3, 4, 6. Cool? Is that making sense? Okay. Hopefully, most of this is review. On page 216 is the do while. Now, the only difference between a while and do while is it's called a post-test loop, which means the loop is guaranteed to run at least once, and then the test occurs. Okay? So I'm going to start this over again. I'm going to start with loop count is equal to 0. Cool. Hey, how come I didn't do int loop count here? Because I've already initialized it on line 89. And if I try to initialize it a second time, it's going to come up and say, whoa, what are you doing? Okay, cool. And then I'm going to do a do, which is kind of weird. And then the while statement is down here. Now I'm going to go ahead and do the while, okay? It's going to be almost identical to the one above. Loop count less than 10. But this is weird, and it only happens with the do while, and that is I have to have a semicolon there. Now this is the only place that I know of where you have to have a semicolon at the end of one of these things. Because I don't have a semicolon here at the end of this guy. But man, I gotta have a semicolon there. So what's the difference? Well, let me grab these guys and put them in here just to see if it works. Okay. Hey, I tell you what I'm gonna do. I'm gonna comment this guy out. Hey, you guys know the cool shortcut? I'm gonna use Control with the slash to comment out a chunk of code. Well, I didn't mean to comment out everything. Let me do that again. I meant to comment out this part. Okay, so this is making sense. So this loop style should work just as well, except it's a post test. We're coming up on the 15-minute mark. Doggone it.